Hello and welcome. I'm Joanne. This is the Turtle Stack. I'll be speaking with a new guest each episode about a topic that excites them that I may know very little about. They have two rules: no slamming, no selling. So basically, we're going to do our best to discuss this topic without tearing down something else or goading the listener into doing anything. This week, I am welcoming my friend Samus.
Hello.
What are we going to be talking about today?
Stars, because they're the best.
Awesome. Let's get into it. What are stars?
Okay, so no, we're not talking about Hollywood. We are talking about those little pinpricks of light in the night sky and also the really big blinding one in the day sky. Stars are gigantic balls of gas burning sometimes billions of miles away, as the quote goes.
Lion King quote.
It's a good quote.
It is a good quote. It's definitely something that was kind of one of my first realization that stars were something other than just a backdrop.
When you think about it, stars that are considered close sometimes have, a light year between them, and that's like the nearest star to us is 4-ish light years away, and we can barely see it in the night sky. And
Okay.
that's how close they are. Yeah, and I think that's a really good example of, I think, one of the reasons that stars and space in general fascinates me is because we see this kind of bridge from this insanely huge, mind-bogglingly big existence or expanse of what we think of as emptiness to just the tiniest, not even an atom interacting with other things hundreds and thousands of billions of times in a second, faster and smaller than the mind can comprehend. It's like the whole spectrum of everything. To give you an example, and this is kind of going away from stars a little bit, but this is where stars really all started. The earliest star formation that we know about is about 200 million years after the beginning of the universe. So 200 million years after the Big Bang is when we finally saw enough matter come together to actually start fusion. Population 3 stars are the first stars in the universe.
Scientists are bad at naming things.
Yes, scientists are very bad at naming things. Okay, so it's population 3 are the oldest stars, population 2 are the descendants of the older stars, and then population 1 are current stars, which are the descendants of population 2, typically. I would just love to switch that around, so population 1 is the first star, because
Yeah,
that would make sense.
yeah, that would make sense. And also, won't stars continue to are they done?
We have not found any population 3 stars.
Okay, but so population 3 were like the first stars.
Yes,
And then from that population 2 came about and then population 1.
yes,
Is it possible that there's going to be a population 0?
yes. Not just possible, but like super duper likely.
Yeah. Did you have a specific start to your interest with space and the stars? Was there like a defining moment that kind of you knew it was what you were into?
No. No, I don't think there was a defining moment. I think I kind of more grew into it. So, me, like a lot of humans, would tend to just kind of stare up at the stars at night and be, sort of awestruck. I think we don't have a word for it in English, and I think we need to. It's something akin to kind of like a wanderlust or a deep yearning sort of thing. I guess my parents must have noticed this because all of a sudden one year I got a telescope for Christmas, and I spent so many hours out in the cold, freezing just everything off, just to try to get a glimpse at whatever planet or star just happened to be in my viewfinder. And the first time I caught a glimpse of Jupiter through my telescope, even though it was just a small telescope, it was I I don't know, it was like a kind of like a religious experience.
So honestly, I remember using a telescope once growing up, and I don't remember really seeing anything through it because I was pretty young, didn't know what I was looking at. So, what do you actually see when you look at a planet through a telescope?
I mean, it depends on how big your telescope is. The more
Right.
magnification, obviously, the better you're going to be able to see what's out there. But with a regular telescope, like I had one of the little kind of basic tube refract. Hold on. No, it was a reflector telescope. And through that, I could see Jupiter, 5 or 6 different moons. So as you go up in resolution and get better optics and stuff like that, you can obviously resolve more. So you'd be able to see the rings clearly if you have a good enough telescope, like a good enough consumer telescope. You can see the gap in Saturn's rings. It's just like that you can sit in your backyard and you can look at that and see it and see the difference from just naked eye to the telescope
Yeah.
is so huge. Again, right there, you're mind blowing. Like you're looking out 200 million years in the past.
Well, and I know one of my favorite things, and I don't remember the name for it, you probably would, but there was somebody who took an exposed photo of the darkest spot in our night sky. There's just billions of different things, stars, galaxies, whatever, in this small of an area that we thought looked completely dark
Hmm.
before.
Yeah. Yeah, it's basically this just crazy small area. I think it's about a tenth of the full moon in size. It's very, very tiny. Very, very tiny. And it's the Hubble Deep Field image is what it's called. And if you haven't seen it, oh my god, look it up and realize that sitting from Earth, you look at that spot in the sky, you see absolutely nothing but blackness. Just blackness all the way down, right? And
Yeah.
then we took Hubble and we pointed it at that little dead spot of sky. And in that one image, just that one image, there were, I think, over 10,000 different galaxies that we could identify. Just just one image. And it's a breathtaking image. It's world altering.
Yeah, it's one of those things, but the correlation that you can put with it as far as realizing how much is out there and how little we can see.
So if you also want to like a kind of a whoa moment, so in our lifetimes, we've kind of always known that, one, the universe is freaking huge. Um,
Mhm.
and
Scientific terms there.
yeah. Yeah, that's what Einstein said, that, verbatim, this place is freaking huge.
Yeah. He
Um,
probably did.
but the idea that the Milky Way isn't the only galaxy in the universe is a very modern concept. Like, just to the 1900s. Oh, God, what were the guys' names? Anyway, what they were doing ended up with the discovery of the cosmic microwave background and the knowledge that our universe is still expanding. I don't know about you, but that blows my mind. Like, it's been how many billions of years since the Big Bang, and we're still getting bigger? And some parts of space are receding from us at faster than the speed of light.
Yeah, I mean, that more blows my mind from the perspective of what is it expanding into. So, a lot of times you'll hear about the expanding universe in relation to a balloon. You draw dots on the balloon when you blow it up, they're all moving apart from each other, as opposed to this is the center and we're moving out from there. But a balloon exists within a room, so the balloon expands into the room.
Hmm.
What is space expanding into?
Well, that's a good question, and nobody knows. Anticlimactic, isn't it?
It is. I would like part of me is like, but I want an answer. The other part of me is like, there's kind of a beauty in not having an answer.
That's
Like,
why space is so freaking cool. Because there's so much that we don't have the answers to. We don't have the tools right now, but we can develop them as we think and theorize and ponder further. And there's just always something to learn and always something new to understand. I don't think humankind will ever be at the extent of its learning or understanding of the universe. The how and the why about space, because we have a lot of data points. Boy, do we have a lot of data points, but
yeah.
we're also missing a lot of data points. And so we have to figure out how to fill in those gaps through studying and through building better tools and all of that stuff.
Do you have a favorite star?
Beetlejuice.
Beetlejuice?
Beetlejuice.
Oh no, we said it 3 times. So
So
why Beetlejuice? Or what is Beetlejuice, first of all?
it's a star.
Great.
It's not that far, and it could literally blow up any day.
Like universal any day or like literally any day?
Like tomorrow. And when it does, it's going to be just incredibly bright in the sky. Like, it will outshine a full moon, even though it's like the tiniest apparent size compared to a full moon. And if I remember correctly, it'll be visible during the day. So you'd be able to see it when the sun is actually out too. And I guess the immediacy of it is just kind of what fascinates me, because if it does actually go supernova within, human lifetime or whatever, we're going to be sitting there watching it. Like,
Yeah.
we're going to get so much freaking data from it and so much understanding from what's going on. It's just, oh, it's so cool.
Okay, so if Betelgeuse is your favorite star, are there any other that are particularly interesting that have like something unique going on?
Oh my god, yes. So, okay, one of the things that really just blows my mind about stars is how big that they can get, like crazy, like ridiculously big. Right now, the biggest star that we know of is UI. I don't know if it's Scuddy or Scooty. I think it's Scuddy. Um, it is a variable star, so it does change in size. But a lot of the stars that we see in the universe at the moment that are the biggest stars are also variable. And I just think that's just part of the nature of being a giant star like that. So this classification is called hypergiants, which we have regular giants and then supergiants and then hypergiants, because again, astronomers are bad at naming things. At its biggest, its radius is about 1,700 times our solar radius. Because of the nature and the science behind how these stars work, it's not crazy heavy like you would think. But anyway, it's only 30 times our solar mass, which is a lot less than it should be, right?
Yeah. So if we took that star and put it where our sun is, what planets would be inside of it?
So for sure, it eats Mercury, Venus, Earth. I believe even at its smallest, it eats Mars and the asteroid. Well, I think it's about maybe closer to the asteroid belt at its smallest. It may or may not eat Jupiter.
You know, one of the things that has amazed me in talking to you is a lot of the facts about stars, I can't figure out which direction they surprise me more. Because on one end, that's huge for a star to be. On the other end, our solar system is huge that something 1,700 times the size of our sun doesn't.
Doesn't just eat everything.
Yes. Which am I supposed to be more surprised by? How big this star is? Because the idea of reaching out to Jupiter in both directions, like we're talking radius, not diameter,
Hmm.
but then also the idea that like there's still numerous planets to get to outside of that
Hmm.
space is big, Samus.
I know, right? And way out there, if you look at the sun from Pluto, it looks like any regular star in our sky.
Wow.
Yeah.
The idea that a planet could basically more or less exist without knowing which star is its. You know, like for us it's very obvious that the sun is kind of a big deal,
Hmm.
where like you were saying, it wasn't that long ago that people didn't realize the Milky Way wasn't the only galaxy.
Hmm.
Heck, if we were on Pluto, it would have taken us generations before realizing that there was a star out there that was influencing us significantly more than the other stars.
Hmm. Yeah.
Okay, so you talked about um the really large star. You said it could be Scuddy or Scooty. I'm voting for Scooty because it's adorable.
I think it's Scuddy, but yeah.
But it still like didn't have comparatively as much weight to it or mass.
It's not as heavy as you'd think it'd be for its size. It's fluffy.
Yeah, so then are there any like small stars that are surprisingly dense?
Oh my god, yes. So this is an area of study that absolutely like just gets me every time, because it's basically a study of real extremes and theoretical extremes. And it gets weird or strange, as some might say. That's a pun, which I'll probably explain.
Explain the joke, please.
I will get there.
Okay.
So The densest stars that we know of are a class of stars called neutron stars. And they are formed basically when a star dies, but that star isn't massive enough to become a black hole.
Okay.
So the reason that they're called neutron stars is because the material inside of it gets packed so tightly that there's not enough space for atoms to exist as multiple bits. So electrons and protons will actually fuse together under the pressure into neutrons. You have the gravity pushing down on it so hard that to go any further together for these neutrons, it would cause neutrons to occupy the same space. They're also insanely, mind-bogglingly, crazy dense. So, like, the pop culture example is that Thor's hammer is built out of the core of a neutron star. Now, a teaspoon worth of neutron matter weighs 10 million tons. If you took our sun and collapsed it into a neutron star, it would fit, it'd be about the size of Manhattan. But every teaspoon of that would weigh 10 million tons.
Just the idea that that can exist and not just throw off everything.
So that is the edge of what can exist without throwing off everything. Like black holes, they border on impossibility. But like we know that there's neutron stars, okay?
Okay.
But the science and the math suggests that it's possible that there could be something between a neutron star and a black hole. And it gets really weird, and this is where the pun comes in. So they're called quark stars. And so a quark is basically the fundamental building blocks of the subatomic particles that you're familiar with, protons and neutrons. So what happens is that the pressure inside the neutron star gets so great that it's breaking down the neutrons into its constituent parts, which is a set of quarks. There are 6 flavors of quarks. One of those is strange, and because of the way they act, at some point, there's a theoretical time at which these quark stars will go to only strange quarks. So you have a strange star, which is why neutron stars are weird.
Strange.
That's a synonym.
Well, thank you for the really good joke. I'll put that probably in the episode description so that we have something nice and punchy to draw attention.
Look, I'm not the first one to make the joke, but it probably is the worst one.
It was a long walk to get there.
It was. It really was.
But I enjoyed it. It was a good walk. All right. Well, I think we are gonna be wrapping up pretty soon here. Are there any other stars or facts that you would like to highlight before we go?
Have I said that astronomers are bad at naming things yet?
It's come up. Yeah.
Okay, good. I just wanted to make sure.
Which we're not gonna put as a slam because it's a fact.
Yes. Yes, and I don't think that you'll find many people who will actually argue with that, including astronomers.
Yeah.
So, a small kind of anecdote. I haven't actually looked into the truth behind this one, but it's a story that a lot of astronomers like to tell. So, back in the day, they were getting these regular pulses coming from a specific location in space that they narrowed down to like a solar system kind of thing. And they were incredibly regular, and then they were always the same brightness. And it was such a regularity, like such precision to it, that the first place that they went was, well, what if this is an alien species or something trying to communicate? So it became this big mystery that they wanted to solve and figure out where this stuff was coming from. And, you know, scientists don't want to go to the alien explanation first, even though our minds all go to the alien explanation first. The project where they were studying these things, they kind of assigned names to what they think. And so they assigned this the LGM. What they ended up finding out is that these are pulsars, and it's basically a star that has a jet of energy going out in one direction, and that star is spinning. And so the flash that we were seeing is when that spin aimed right at Earth, okay? So
Okay.
we ended up calling, so it pulsed, right? So we called them pulsars because we're bad at naming things. But the LGM acronym that they originally used, it was actually for Little Green Men because they
Oh.
wanted it to be aliens so bad. And I would give anything for pulsars to be called LGMs.
Yeah.
Like, they had a good name and they just abandoned it. So, um, I don't know. I think that's a good pile of things that I like about stars and why I find them fascinating and why they have done so good at capturing my imagination and my interest and my questioning and my wonder. Since I was a wee little thing. Um, there are a lot of resources that I use on the regular to kind of research more about these things and to learn more as the sciences progress and all that stuff. PBS Spacetime is a channel on YouTube that just does a fantastic job on exploring things like cosmology, planetary systems, uh, Einsteinian physics, relativity, quantum mechanics, all that kind of stuff. They do challenge questions, and they have try to answer their challenge questions. You can get prizes and that kind of stuff. I have not won any prizes. The other one is Kurzgesagt, which does they're very broad in the topics that they actually address, but they do a lot of stuff with space.
Can you spell that?
Kurzgesagt.
Yeah, I don't think the listeners would have guessed that spelling.
Like, it's an excellent channel. Their production value is very high, and the amount of work that goes into not only the animations that they use, but also checking the facts that they have is like mind blowing. And then there's Titanium Physicist, which is a podcast that I listen to on the regular, and they do just an excellent job at taking some very advanced subjects, but they have these scientists explain them to regular people.
Samus, if people want to get a hold of you to either discuss star things or see what you are about out there in the real world, is there any place that they should look for you?
So you can find me on Twitter, DeviantArt, Facebook, and Instagram as Samus Fairchild, one word. I pretty much anywhere I am, it's Samus Fairchild. Or you can find me on Discord at Samus Fairchild #0042.
Fantastic. Well, thank you very much for your time. I definitely enjoyed talking with you and learning more about stars.
Thank you for the opportunity to gush.
If any of you are interested in gushing about a topic you love on a future podcast, please email theturtlestack@gmail.com. If you're interested in reaching out and following, I am on Twitter, Instagram, and Facebook as The Turtle Stack. Just remember the rules: no slamming, no selling. Feel free to share your favorite space or star fact with me. Thanks for listening.